Yep. So hopefully we do not get lead out of here. We use the Spark Core and the Edison. We're using the Spark Core as a counter, which is meant to be held in the pocket, so you can press the buttons through your pants. And it uses Dynamo to store and communicate, so you can press it and count up the count. You can go up, you can go down, you can clear for a new shoe. And then we use the Edison, which is meant to be strapped inside of your pants to your leg. We have a vibration sensor, which should, well, that just senses it, but that's later. So the vibration sensor should sense something like a tap of your foot on the ground. And then we actually used a relay, because when the physical switch on the relay kicks on, it will create a thunk, which you can feel. So when you tap, you can't really see it, but you might be able to see the light on the relay flash. When you tap your foot, it then spits back and reads you back the count, the current count, by tapping you on your leg. And that's pretty much it. It's pretty straightforward. One person sits at the table, keeps their count, then your player comes by, taps when he needs the count, silently gets it. Simmer down. Number of services, pretty much just Dynamo.
Edison, Spark.
And then the Edison and the Spark. But Dynamo is the only real service that we're using, and that's just to keep the count.
Okay, DynamoDB. Awesome. Question?
Yeah, I'm Mike George. Nice to meet you.
Hello, it's Joe.
I'm about 4 gin and tonics in, so pardon me. What real problem are you trying to solve with this?
Winning.
Okay. Let's go beyond that for a second and think about the world we exist in, and what do you want to accomplish with this?
Sure. So like the chance or the goal or the object would be to give someone a way to collaborate without visible signals that a camera would be able to see.
I see.
So you would have your player would be able to leave the table, switch tables to blow off heat, come back, the counter keeps the count, the player's hands stay above the table, there's no signaling, nothing to see.
There's some casino security guys that have showed up at the
Right.
I'm fully expecting the handcuffs when I leave.
How would you hide it?
You would have it strapped to your leg.
Strapped to your leg.
Okay.
So hopefully no one would be touching you.
And the vibration sensor?
Yeah, I mean, it's just the switch. I mean, we would use some kind of actual vibration chip if we had one, but the relay works really well, actually. So no one should be able to feel it.
So have you tested it downstairs?
No. No. Not planning on it.
Cool.
Alrighty, any questions?
Very cool.
All right, give it up.
One more question.
For Blackjack Counter. Thank you.
Hi, everybody. I'm Matt. I'd like to tell you a little bit about my house. It was built in 1900, and every time that it rains, I get very nervous because there's tiling around the outside of the house that drains into the sump pump, and if the sump pump fails, my basement fills up with water. So I have a backup sump pump that's actually water powered. It runs off the pressure of the city water, but I'm still very nervous when it rains. Ohio. So this is my basement monitor. It's got several things. It gets really humid down there, so it's going to have a humidity monitor. We didn't have a sensor for that here today, but I have one at home. Temperature monitor. It's got a display. It's got a water sensor that detects water, so that's going to go down into the sump. So I've used this thing polls regularly, updates the display, and also it sends its data to Dynamo. And when it's in the error state of water being in the basement, it actually sends a notification to SNS. So I was going to send the notification to myself, but I have an iPhone, and I heard that the iOS stuff is more difficult than the Android stuff to configure. And my wife has an Android phone, so I'm just going to have her take those notifications, and she can call me. So that's pretty much it.
So are you planning to install it in your home?
Yeah,
for
so
real?
this is the first phase of my larger vision of monitoring everything in my house. I want to monitor the temperature on every floor. I want to monitor the temperature of the intake versus the exhaust of my furnace versus the current on the motor. Like I have this, I want to monitor everything.
Great.
So yeah, this is what I could do today.
Have you tested? How did you test it?
Well, so the temperature, I can just put my hand on.
I want to see you test the water.
Yeah, okay.
Not the water.
He's licking it.
So that does update.
Okay, that was
And I tested the water with just dunking it in water. I also tested it in beer, but it doesn't actually work reliably in beer. But I think that's okay. If my basement's full of beer, I'm probably pretty happy.
Good answer.
Good job.
Good one. Which services did you say you used?
Dynamo and SNS.
All right.
Very good.
Very cool. Give it up for basement monitor.
All right, so we're team 6. Can everyone hear me? Yeah. Okay. And we are tackling the largest problem facing growing. Okay. Can I pull it out? All right. We are tackling the largest problem facing growing organizations. Okay? So I want to tell you a little bit of a story. So I'm the co-founder of a company called Localytics. We do mobile app analytics. We started 6 years ago, and we use we use AWS across the board for everything. Thank you too. So we've encountered a lot of challenges along the way. All the typical challenges of a growing software company. We've had server fires when we had more traffic. We've had mismanaged infrastructure that needed to be cleaned up. We've had bugs in our code and all that kind of stuff. But as a growing organization, the biggest problem that we've ever faced, okay, what is the biggest problem that we've ever faced? Bathrooms. The availability of bathrooms in the office. So this is what happens in a growing organization. Employee count is a line that keeps going up, and bathroom count is a step function. And there is an unhappy zone in the middle right there. Yes. So, given that, okay, as a typical employee at a fast kind of growing startup, what's the problem that you encounter? When you go to the bathroom, you get up, you walk all the way across the office, and this is what you're greeted with, right? That's millions of dollars in lost productivity of employees walking across the office. So we set out to solve this. So we are Stall Patrol, and we are an automated solution for tracking bathroom availability and much more. So how does it work? Well, we place a sensor in the stall, a motion sensor that tells you whether or not there's someone in the bathroom. You can go to a web dashboard and see the occupancy of every single stall. Yeah. On top of that, when you're in that dashboard, if you want to request access to the bathroom, someone's taking too long, you can press a button and they'll get flashed. One thing we didn't have time to add is we really wanted messages, so you could write them messages. Okay. All right, so let's see how it works. So I'm going to bring up the actual dashboard. Okay. So what you have right here is we have one stall that's fed through the actual device and then a simulated one on the second one. And you see that it's telling you when the last time motion was detected. And you got a check mark right there, right? So that's why we hid the motion detectors. We wanted to get that check mark. So if I take this off, and see, the check mark goes away. And now you can see that the last time someone moved in that bathroom was less than a minute ago. So perhaps you might want to wait. But if you're getting impatient, you click the request button, and bam, you flash them. So let's see, how do I get back to the presentation? There we go. So that's pretty much it. So we were thinking about other things we'd do, like I said, messaging, all sorts of queuing. You could have a list, a line of people. You get a push notification on your mobile phone when you're ready, when you're queued up. Things like that, maintenance buttons. Oh, we need more toilet paper, and I'm sitting on the John right now. Someone please help me. Stuff like that. So basically, we're Stall Patrol, and we're saving corporations millions of dollars in time and money. Questions?
Which services? Specifically, which AWS services are you using here or leveraging here?
So we're using DynamoDB as well as DynamoDB to track the stalls, S3 to host the website, the dashboard. Yeah, and that's pretty much it, right?
Could you add a feature to electrify the seat?
So
Really buzz them?
another thing that I would really like to do personally is have a vibration sensor on the toilet, and so you could see like how violent someone's.
That is funny.
Yeah.
Yeah.
And I'm not joking. I'm going to take this back to Localytics and install it in the bathroom. No, definitely that's happening.
There's an Amazon Studios series, and like we can make out of it.
Yeah,
Simple bathroom service.
that's great.
Thank you.
Great, thank you. Good job. All right.
Good job.
Excellent, guys.
All right, our team is, we call ourselves RTA, Real Traffic Analysis. So I am that old codger on your street that yells at people as they speed by my house. I'm very concerned about that, waving the cane at them, telling them to slow down. And we as a team, we brainstormed this, and we thought that there's a lot of value in knowing traffic patterns and doing it cost effective. And so we came up with an idea to measure patterns of traffic that go on residential, business areas. Typically, your Department of Transportation's typically only measure like freeway traffic using cameras, very expensive methods. Whereas with an easy sensor, which we have here, which does it through sound. Let me turn it on, let it calibrate itself. We can measure traffic patterns on a specific street. So if you go to gabechino.com/traffic.html, you can actually see this on your own, in your own browsers. And that's coming up right now, and it's going to calibrate itself against this wall, so it has a baseline, and then after that it can measure anything that moves past it. And once we start getting some data in there, we actually have 3 devices connected. That's why you see the 3 right there on the screen over here. If you guys want to start putting some data into that, every car that drives by increases that. And this is real time. This is going through, this is using Spark, so it's using the Spark API to get that data. We're actually pushing that back out into Kinesis, and we're going to persist that into Dynamo. And what can be done with that? Why does that matter? Who cares, right? Well, number one, governments care. They want to know how to zone certain places. So yeah, that's important. They want to know where to put police so they can get that revenue in for the city. So yeah, that's a freebie. We could actually give these devices away to the government at a price point of under $100. Who cares, right? But the government, they would love these, because why would we give it to them? Because they'll let us put it on their street signs that they've already paid for. And so we slap it on their street signs. But then how do you monetize that? We have data. Data is everything. So that's the beautiful thing about the Internet of Things, is I slap this up on a stop sign with a magnet, and at the price point we have, and this is my nervous habit, I'm just going to keep raising these numbers up. And we have it out there. We can do data analysis. We can do predictive analytics. We can decide the value of a house on a street due to its traffic patterns. Think about going to Zillow and getting a, hey, how much is this house worth? Oh, it's this. But look, this is the quietest house on the block. It gets 2 cars past it a day, and that's the owners of the home. So that kind of data actually can let potential homeowners know where to buy, where to build, what's going to be of value. So that's really it. We try to keep it simple, but you can see for reasonable amount of money, you can get real good measurements on patterns of traffic, not just on the freeway.
What services are you using?
We're using the Spark service, the REST services they have, and we're using Kinesis as well. So we're creating a Kinesis data stream.
Yeah.
I thought you said Dynamo as well.
Yeah, we persist it out for future real data analysis. If people started slapping these around the city at the low price of $10,000, you get 100 units out there and really get some good data very quickly.
Did you say something you used to sound, or is it motion detection?
So this is all it's motion. And this could actually detect speed. We didn't build that part of the algorithm out. This is just, is there something there? Did it move? Is there something there? Did it move?
So nothing would sound.
So nothing would sound.
Sorry.
Eventually you could measure that, have that data as well for various places in the city. But yeah, that was our idea.
Can you tune it for cars versus bikes versus cats?
You could fine tune it, yeah, definitely. Because you can know when it starts, how long it's there, especially if you're going very rapidly. And this you have to actually saunter by it to get it to work. But yeah, we could speed it up and actually know what type of vehicle possibly could be going there.
Great.
Alrighty.
Awesome.
Thank you. That was.
Because while they sort that one out. So the idea generally this is PagerDuty plus sort of really. At the moment, I use PagerDuty at my company, and the phone drives me mental because I get notifications of every kind from like Twitter to Facebook and to whatnot, and I have trouble sometimes during the night that'll wake me up instead of PagerDuty, and it kind of annoys me. And it was to a point of trying to find something else, something's dedicated just for giving me notifications. And I can just leave it wherever I want. I don't have to worry about where my phone is. This will just continue to function no matter what. So the services we've used so far are EC2 to run the node process we've got to handle all of this, which then uses CloudWatch, pushing into SNS, and then pushing to 2 separate SQs to monitor both devices. So the idea is you'd have both the pressure sensor, or the first device here, and paired with the other one. So this one gives you a bit more of a readout about what's going on, and you can use this to control it. So the idea is that's Alice's pair, and this is Bob's pair. They wouldn't be in the same place, obviously. So we're just going to do everything all right? Okay, we're just restarting our node at the moment. And then we'll do a quick test. We'll start off with triggering a CloudWatch alarm just manually on the laptop over here because we don't really want to camera a machine into floor to make it work. And then you'll see both devices will light up, and they'll give you a readout on the display about what's going on. At that point, you can then acknowledge it, and then both devices will be quiet. So if you had 2 people on call, the first person to acknowledge it will then make sure everyone else doesn't get woken up too much. Okay, so we're going to trigger the CloudWatch alarm now, and it's going to. Both of them have buzzers as well on the side. So you see they go off straight away. They start off with this really offensive, annoying light to begin with, and then they go to this sort of slightly nicer rainbow. And then so Bob's going to acknowledge it by just pressing it or just pummeling it into the floor, which would usually be what I would end up doing. And then you can see on the readout, it will tell you who, I think you can see on there, who silenced it, and so you can see who's dealing with it at the time. Beyond that, if you had then dealt with that issue and then you decided I needed more people to help me, you essentially have a panic button. So Alice is going to freak out about what's going on, and then it's going to alert every other device that's connected to the system at the same time. So at that point, then Bob can just say, yeah, I'm going to be on that with you as well.
Nice.
If we had more devices, we'd have more connected, but obviously we only have 4. So that's pretty much it. Yeah.
Who do you think would buy it? Restaurants where they want more beer?
You could, yeah. I mean, that's yeah. If your bartender isn't paying too much attention, just slam your fist on the table. But I would probably use it, yeah, for just literally my ops.
Amazon,
I can throw this across the room, but I can't throw my phone. So
Amazon might buy that.
What's the thing you put on top of the button there?
It's a coffee lid because I was getting so frustrated looking at these really bright LEDs all day.
Yeah.
But also at night it would
cool.
be a bit more diffuse, cool. So a bit nicer to look at.
Hey, that's great. Awesome.
Yeah, any other questions?
This is great.
Yeah. Thank
all
you.
Right, cool. Cheers. Thanks, everyone.
Great. So we'd like to talk about the problem with TV measurement. So this is a real problem. It's a $10 billion problem. At the moment in the UK, all TV programming and advertising rests on a very small panel measurement. And this is done at the moment with proprietary measuring tools, and it runs on a batch process overnight. So the equivalent in the US is Nielsen. It's called Barb. And so how do we know that that measurement is real? It's a very, very small percentage, 0.01% which is how it's keyed against all these demographics. So what we try to do here is say we can improve that measurement by knowing that we've got someone using the remote control, knowing that someone is in the room watching the TV, and then checking all the different devices for that are using the online players to say whether they're actually viewing content. So what we've got here is 2 sparks, and the sparks represent 1 for the remote control and 1 for the TV meter. Three sparks, yeah. And the third one, which there's 2 remote controls and 1 meter. We didn't get the Edison working, which was to then do the sniffing of the packets. What we're doing is capturing this data in the back end in Kinesis, and then we've got a custom worker which is running on Elastic Beanstalk, aggregating onto DynamoDB. At the moment, we're displaying it on the console, and in logs, we didn't get to do some nice graphs. The team is drawn from Australia, Brazil, and the UK. And now do you want to plug in your laptop? We can just show some of the back end.
So what we did was we needed to emulate the remote control. So we took one of these and simply used the 4 buttons to emulate a 15-key keypad, and that enabled us to be able to depict the different channels that a user might be selecting for what programs they want to watch. On the head end, we also had a ultrasonic movement detector, but the sensors didn't work. So we ended up substituting a sensitive microphone to act as that. And what that tells us is if there's someone actually in the room. So if there's no one, if a program is selected but no one's in the room watching it, it's of no value. And we had a pair of remotes because you could have multiple stations in a house.
So just a small demo, this is, I believe that's actually one of the 1 or 2 projects that actually implemented Kinesis workers reading this string. This one is written in Java. There is a current instance running on AWS Elastic Beanstalk, and it's logging the data here. It's not showing due to the zoom, but it's registering the data. So on the other hand, we do have a service. There is another service here. Just a moment. People don't know how to do keyboards anymore. Anyway, so when I update here, it should, but unfortunately I have a curse that I always fail when doing demonstrations. Bad joke, my bad. Anyway. When you upgrade, when you update here, it shows the updated data, but actually, and it's stored it's running on AWS Elastic Beanstalk using a Kinesis worker, using DynamoDB, and we are not actually putting data into the DynamoDB. We are doing real-time aggregation of data, updating counters, atomic increments, some half-dirty operations, and there is some room, there is some CloudWatch and SNS stuff we didn't implement for that. But overall, we came successful in using Kinesis to merge the strings coming from Spark and aggregating to DynamoDB and generating data. That's all. Questions?
How would you get the users to use this remote?
So in this panel, the phone TV panel, they have to register, they have to log in. So they're a panel household. So we'd replace the remote with this, and we'd replace the TV meter, so that we're now not collecting the data through these proprietary devices, but through these through the Sparks.
And so this gives us much better quality data than what the existing systems can deliver.
Yeah.
There's a big question whether the advertisers will actually want to use it, because it might give a lot more information about viewing.
That's right. And of the $10 billion opportunity, we'll take $1 billion and split it with you.
That's clever. That's great.
Good. Awesome. Thank you.
Awesome. Thank you, guys.
Hi there. We are Sensei Grow, and this comes out of a problem that I've had at home pretty much every summer, which is we have a small backyard, we have a lot of trees, we have a lot of other plants, and whenever I go and look for things to put in there, they die. They will, like the hostas will burn up, the daylilies will die of malnutrition, and so the thought was that you could have a connected device that would monitor the conditions and then suggest what plants might actually survive in a particular spot. You could buy the device and you could put it where you wanted to plant something, and it would go and collect data over a period of time. And then when you want to know what to go buy, then you can just take a look and it'll tell you what plants will survive. So we based the project, we used the Spark core to collect the sensor data and push it online, and we used a temperature sensor, a light sensor, and we figured since it was sitting there in the garden, like what if you wanted to plant some strawberries and some little critters wanted to go eat it? Well, we have a motion sensor, so you could also use it to scare animals away from your desirable plants, and then that also has the nice effect that you might want to buy more than one of them. So, we'd use it to just figure out you have a spot, you want to know what to grow. So, the senseis will poll the sensors, and we use Kinesis to collect the sensor data, and we store it in DynamoDB, and then we have a front-end interface that displays the data. And so the front-end interface is running on EC2, and we have a simple Sinatra app set up on an EC2 instance that aggregates the data and sends back JSON that's displayed by the browser. So, right now we have a light sensor, a temperature sensor, a motion sensor. We were asked to disable the buzzer because it was causing a lot of annoying buzzing sounds as people were walking by. So that won't be part of the demo. And the implementation is done on the Spark core. So. Let's see, where are we at? Oh, we are at the demo, so I'll let you take the microphone. All right. So right now we have a here I can get rid of this, but you'll see that right now we have, just based on the amount of light the light sensor has, it's a little bit askew, so it's part sun, and it's reading about 68 degrees, and it is making a plant recommendation. I would presume as we mature the product, that we might have a better database of plants, and anyway, so we have that. So that plant is eligible for part sun. And then we also have shaded and full sun and other sorts of plants, and you can see that we're querying an API that's returning the data. This is the IP address of our EC2 instance that's also running the worker that's pulling the Kinesis data and storing it in DynamoDB that you guys were kind enough to set up for us.
Also, just to give a demo of the motion sensor, in case of any animals or something goes by our plants. And based on the motion sensor, it would detect the activity and start the buzzer to scare them away. So you can plant many sensors around your plant area. Depending on the temperature and the light, you can use them. Any questions?
Does it have any location-based features, so you can
you can tag your sensors depending on which zone it senses. So
more like enter your zip code, so it has like patterns.
so you're talking different zip codes of farms?
That would be really good for grow zones because if you're setting it up in the summer,
Yeah.
then you'd want to know kind of where what zone you were in, so that you got a frost-resistant plant
That's right.
if you needed to. That would totally affect the affect the suggestions. And there's also soil conditions that are specific to environments and stuff like that.
No, I would just put a GPS chip in that beast, and then you know.
Sell it to wineries.
Yeah.
They'd pay a pretty penny.
Yeah, absolutely, and that's where we tried to make the data format extensible, because you might also want to do things like measure the soil pH and the moisture and stuff like that, because certainly if you're cultivating grapes, you'd want to have you'd want to know a lot more about the soil, about its chemical composition, because that would affect the way the grapes grow and the wine tastes.
Lots of practice.
Could you put in a super big buzzer to get rid of unwanted visitors?
In a world where water is
That's true. Yeah, it's good. I like that.
Put it in the bathroom. Great.
Alrighty, awesome. That is.
Hello, good evening. So I'm Alvin, this is Ali, we're Team 20. And pretty much the problem that we're trying to solve is the flood detection and prevention. So actually, majority of the major cities like Manila or maybe other cities, the main issue is that whenever it rains hard and you're driving around, you don't know what kind of roads that are flooded. Or sometimes there was also one time when I was parked on a street, it rained hard, and I just came back, I saw my car floating. So what our solution is that using both Edison and Spark chipsets and using a moisture sensor. What we plan to do is to have these sensors installed on poles that divides the roads, parking lots, or places that are near dams. So whenever there's a flooding, we can do a notification, and also make sure that dams and the floodgates can be opened whenever it's needed automatically. So for the demo, I have here is Ali right now. He has his Spark core here reporting moisture information to the server. So we have this servo in here that's supposed to be. We have a servo in here that is actually going to control the floodgates. So let's say, for example, we put so this one moves, opens the floodgates, and at the same time, I should be able to receive an SMS. So the SMS is quite delayed since I'm not using. Here we go. So let's say, for example, if I'm in an area that's flooded, I will just get an SMS, and the floodgates will be open automatically. Big vision for this one is that we want to have a GPS sensor in here, so that we can have a bunch of these devices across the board, reporting directly to Amazon, and we can do some historical data. So the services that we've done, we have an EC2 server. So I wrote a Python server that collects information from this one, as much as possible, the complexity is out of these devices. We use Twilio to be able to send an SMS, and DynamoDB to collect data. So that's it.
Great.
So, can you say again what AWS services did you use?
We have EC2 and DynamoDB. And for SMS, it's not Amazon. We're using Twilio.
Okay. And how do you detect rain versus flood? Because in a rain, you don't want to trigger, but on a flood, you do.
Yep. On this one, the moisture sensor, even though you wet one place in this one, you have to make a contact.
Okay.
So as soon as it gets contact, then that's the time that we're going to assume a flood.
But rain can do that, right?
As long the slight chance will be very low. So say, for example, it's raining on this one. As much as possible, there have to be a contact. So there might be just one side's both wet, but they're not actually in contact.
You can also enclose it in like a barrier or an awning or something.
And in these areas where you would put them, is there Wi-Fi?
Actually, back in the Philippines, we're actually building some smart cities where there's going to be some Wi-Fi routers on the electronic poles, so that as soon as we have those connectivities, we can have these devices installed around the place.
Okay. Good answer.
Thank you.
All right, thanks.
All right, so yeah, the main point of this is we've started to see a big increase in the number of smart thermostats coming into the market, but none of them handle the notion of homes that have a full climate control system with multiple zones. Typically, they've got sensors in a single room that are looking mostly at temperature. Some of the better ones are now looking at occupancy and such. So what we're looking at, I actually designed this around my home. It has 4 different heating zones using radiant heating. And to really do that well, you've got to look at occupancy. You've got to look at the light coming into the room that's heating the floor. You've got to look at the temperature of the floor itself and the temperature of the air. And then you've got to be smart enough to understand the interaction between the zones within the home, so that when one zone is causing a little bit of heat in another zone, you don't misunderstand that and end up letting that zone get too cold. And that's a lot of brains that has to be in there. So what we've got here is both a Spark Core and an Edison, which is plugged into the laptop over here, and a whole bunch of sensors. And right now we've only got a couple of those plugged in. And all of that data then goes through Dynamo through Kinesis up to Dynamo, and then gets processed in a machine learning application, which we obviously didn't write today, which is able then to kind of look at the flow between the different zones and determine when to call for heat and when not to, when to call for cooling and when not to. And you can also integrate outdoor temperature sensing and so forth. So what I've got is this dial here, lets me determine what temperature I want the home to be, which is also displayed by this LED. And so like right now we're asking for lots of heat or lots of cold. And of course it's going to unplug on me. At the top we've got the actual temperature being sensed up here. And then this one, we've got a buzzer for freeze control. So if you drop below freezing, it gets really mad at you and can use SMS to send off alerts, hit your pager, whatever. And then this second knob is here for the sake of the demo. Static temperatures are really boring in demos, so this lets me change the theoretical temperature in this room and dial it up. And then the lights on the sides here, right now we're calling for heat, versus right now we're calling for cold. So that's kind of what's going on here. And then we have the interface up here that's showing the data coming into the system. Well, we're using Dynamo and Kinesis, and then would be using other things, but we're not yet.
I have a question. So how does this solve more of a problem than something like the Nest thermostats solve today?
Absolutely. So a couple of reasons. The Nest handles one zone, and up until very recently, only has sensors in one room. This can have sensors scattered throughout the house, but it also understands that the heating is hitting different zones of the home.
But that's not true. I mean, I have 4 zones with Nests right now.
Right.
On each zone.
Right.
How many Nests do you have?
But what those Nests...
Four
gotcha.
devices.
Yeah.
1 per zone.
Yeah.
So
right.
Explain how that's
But what you have, if I understand it, and I'm not an expert on the Nest, is you've basically got 4 independent heating systems.
Right.
They know nothing about each other.
They know the temperature in the space that they're in.
Right. But effectively, you've got 4 homes on 4 different thermostats and 4 different heaters, as far as the Nest is concerned. What this lets you do is that the brains that are controlling the boiler and the zones are aware of all of the zones. So it can do things like, these zones are next to each other. One's calling for heat. The one next to it's not calling for heat yet, but it's going to be. I can tell it's going to be. So I'm just going to turn them both on together. Particularly, this is important hydronic heating, where I've got a boiler that really doesn't like to run one zone at a time.
Yeah.
It's more efficient if it runs 2 or 3. And so because the system is aware of the zones and how they relate to each other, and it becomes more aware over time using machine learning algorithms, it's able to intelligently say, okay, I'm going to turn both of these zones on for now. It's still going to stay comfortable in both rooms, but my boiler is going to be more efficient by running them together.
Okay. Great.
Great.
Thank you.
Awesome.
Thanks.
All right. So it's a little crude. I had a team of more, and then it was just me. Everybody left, so I was on my own. But anyways, so working through this, came up with the personal turbulence monitor. Basically, what happens here is it has a, an accelerometer, and as the accelerometer moves, it records the different data, but it also sends whether or not there's input from the touch sensors and LED light. So what happens is you're in an airplane, there's turbulence, and this can detect movement. Another thing that didn't have time to finish making the link, but leveraging it with TripIt APIs, tie it into your account, and you can see your travel itinerary. And so it can go in and say, okay, I know you're flying on this flight and sitting in this seat. And so it can map out turbulence on flights based on your seat location and where you are. And with that information, it can also look up weather info and give you some data analytics into how the turbulence is affected on different routes or based on weather, or whether or not the upcoming flight might have turbulence, and where a good seat might be to have least turbulence during your flight. And then it'd be nice if I had an app developer. I don't, but you can either do like an app input to say this is uncomfortable turbulence, or you can push the button, which the light will light up, and then the indicator will beep saying that it's received your indication that the turbulence is uncomfortable. In collecting all of this data, you can go through and maybe provide this to the airlines and say, here's big data on what customers feel is comfortable or uncomfortable turbulence. Here's the flights that have the most turbulence recorded by customers. So there's a lot of stuff that I feel that could be done with personal turbulence monitor.
What AWS services did you use?
So this is streaming through Kinesis and then storing in DynamoDB, and then there would be an EC2 instance running all of the calculations, pulling the TripIt API information, collecting this, and providing you with the services for data analytics.
How do you connect to the cloud on the flight?
So that was one of the things I was thinking about. Most flights nowadays have GoGo in-flight Wi-Fi, and possibly in striking a deal with GoGo, automatically allowing these turbulence monitors to automatically connect to the Wi-Fi and not have to be challenged or authenticated. Yeah. And in that manner, maybe providing either something back for them from the airline, or advertising something that to do a tit-for-tat sort of deal. So that, or in the case that Wi-Fi is not available on the flight, maybe like Bluetooth low energy to your phone, and then have that store, and as soon as Wi-Fi is available, have that uploaded to the cloud.
Okay, cool.
How about selling it to a driving school teacher?
What's that?
To a driving school teacher.
Good idea.
How scared are you while the teenager's driving?
Exactly.
Thank you.
Thank you.
All right, thank you so much.
Hello, guys. Good evening. Our purpose here was to see how many tweets we have on the name of our company or something. Here we're going to use the hashtag of the AWS IoT HackDay. So if possible, I want you guys to tweet with that hashtag so we can see the sensor. Where's the? Oh, sure.
Our project is to stream using the Twitter API, and yes, that's the first tweet, second one, and
here's the number of tweets, and the last tweet from Boff Bausch, now from Big Click Dean.
Nice, and there's more tweets. The LEDs will going from red to green, and there's two reasons you build that. The first one is in our business. We are a startup company, and we are growing a lot. So the noise is always keeping up. So there's the first reason, because together with the Twitter API, that is to monitor our social networks, we install a noise sensor that shows when the decibels is more than 70, there is a blue light that shows up there. Make some noise, Guilherme. Okay, thanks.
Well, with the raising noise, the blue light flashes, so it would tell someone that is making noise in the company that, oh, be quiet, please, because we have an open, wide room with no walls, and everybody develops in that same room. So the sensor with the sound for the sound is for that purpose. So we don't have to shh, be quiet. And the other one is for our marketing team to see how is our name on Twitter, and later we can instead of the Twitter stream, we could get the Jenkins continuous integration build or something that or get the number of bugs registered in our ticket systems on our project management system. So this could be visual to our development teams to see the color based on the number of bugs or the number of tweets and stuff like that. So the last tweet right now is app ort zuvampk. There's still 20 tweets. I think if it passes from 30 tweets, it will go ring. 30 more tweets. Yeah.
We're so slow. If I put there Justin Bieber, you see how fast it grows. Justin Bieber now. Starting 3, 4, 5, 6.
16, 21, 24, 25, 27. We're using Amazon Kinesis for the stream of tweets, and then we are putting it on DynamoDB for analytics later. And that's pretty much it.
The second reason we built that is to make some kind of a buzz meter from a conference like that. We want a real-time way to get if the audience is liking or not our presentation. So
make some noise. I think it bugged somehow. I don't know.
There's a blue light like right there. It's a kind of lamp.
Any questions?
Yeah. What Amazon services did you use?
Kinesis basically for the Twitter stream, and DynamoDB to store the data. That's it.
Cool.
Thank you very much.
Thank you.
Great. Okay, so we're SmartHouse. When we're thinking about the Internet of Things, the place where we have most of our things, it's at home, and none of them are connected. And all of the solutions we have at the moment, they're really expensive. So we found this was a great opportunity to test if we could build something that would connect most of the devices at home and affordable, so we could just dominate the market, because it's really expensive at the moment. And when we found out it's possible to create things that are much cheaper. So we had many ideas to control, monitor, and interact with our homes. For this presentation, we have a few features, but we had many more ideas. If we had more sensors, we could just build many more things. So first of all, we have a monitor of the temperature. So we have a mobile application, so you can see what's the temperature at your home. You can see if your shades are open. And we have an alarm for our front door. We had the monitoring for our windows, if it's closed or opened. So you can see now that we have the temperature on this building. At the room, it's 26 degrees. We also built an application so you can control your air conditioning from your mobile. So you can just type the temperature you want, and it will talk to your air conditioning. We don't have an air conditioning, but we have the LCD that's playing as our electronics at home. Sorry. Você segura aqui? We also have, we built an alarm for our front door. So we're from Brazil, and robbery, it's a big issue in Brazil. So we found, why not build an alarm? So you can just go, você não consegue segurar lá? On your mobile app, turn it on, and
busted.
And you're busted. We built email and SMS sent to his mobile phone, and we're using this thing. And we have the email already. You received a home alarm. Volta lá. And we also built a sound alarm, so if you want to leave, if you have a baby or just want to check the sound in a room, you can build the alarm, and Antonio is going to simulate a baby for us.
Cute baby.
So these are the features we've built during today, but we could have built many more things, and they're very cheap. So we see this has a lot of potential because you can just connect all of your devices at home. It's really easy and a lot cheaper than the solutions we have at the moment. And we used Elastic Beanstalk for the application, Dynamo, Kinesis, and SNS for the and the sensors. We have the barometer for temperature, the LCD, the angular rotation thing, and the sound sensor, and the light sensor. Yeah, we didn't show the shades. Oh, we built an automatic shade closing and opening, so. Tá aparecendo aí? Tá aparecendo? Dá pra ver? Apareceu? So it closes your windows if it gets to a lumen.
Yeah,
Yeah.
it did.
Awesome. Can you see the LCD?
Any questions?
Yeah, very impressive app. How would you connect to all these devices, the shades, etc.?
What do you mean? Sorry.
So right now you're showing that you're closing the shades, but you're not actually connected to shades. How would you connect to them, and etc.?
That's a good question. We've connected them to an LCD at the moment, but it's probably very easy. It's just a message. So if you can receive and send messages, you can just it's just an engine, and you just rotate. For example, the shade, and at our rooms at the Venetian, it has an engine, so you just have to connect an engine here.
Good answer.
Show us tomorrow you're controlling the shades. That's great.
Well, easy, yeah.
Very good.
Thank you so much. This is pretty cool, guys. SmartHouse.
Yes, we were Team 34.
Team 34, Edison Fire.
You might have known us better as the winners of the Maraca Challenge. We are ready to rebrand as the Edison Fire. What you're seeing is a sample of our game console. This is what we like to call our MMORPS, or a massively multiplayer online rock, paper, scissors game. So Jonathan is going to use our game console to join. He's representing one of what could be many, many in the field, clients connecting to our game server. He is playing against Amazon as the as the game server. So we have now many clients, normally rock, paper, scissors, a one-on-one game. We have many people playing against Mother Amazon. And those that lose are out of the pool until we continue additional rounds coming down to a one-on-one, and either somebody wins or Amazon wins. Yep, let's... there we go.
Okay, yeah, go ahead. All right, so you got to be careful touching the bottom of this. I actually put my finger across a couple of things on the back, and it rebooted, so it took me a couple minutes here to get it back up. So again, the gaming market's like $54 billion a year, and there's a big untapped market for really low-cost game platforms. This is as low cost as it gets. Very low cost. I built it with a broken pen and a paper plate and some twisties. Okay, so here it says touch to begin, so I'm going to touch the touch sensor. It's loading the game here. It says use joystick to choose answer. So here we're playing the particular game we've loaded is rock, paper, scissors. I can go to the right and choose paper, go up, choose scissors, go to the left, choose rock. I'll choose rock, and then push down to send it up. AWS chose scissors, so we won.
Sorry, Amazon.
So we can try it again. It's going to join the game again. Touch to begin, touch the sensor, it's loading the game. Choose joystick, I'll choose scissors this time, and then push down. AWS had rock, so we've lost. And so you can play for as much as you want to play here. My 4-year-old daughter would actually really love this, so she'd play it quite a bit, but.
We're pre-revenue and ad-free at the moment. We'll rule nothing out. So if you think about a typical game controller, it's a dumb controller relying on a smart console. We, by making the controller internet connected, can make a very low-cost controller and leave the intelligence in the cloud. So in this particular form factor, we've got a touch sensor, a joystick, and an LCD. We could have other form factors. In this form factor, we might be able to run a dozen games. We might be able to have another form factor with a different set of components. If you think about the Gen X crowd who wants to relive their childhood, I grew up on a Atari 26, well, all right, even before that, I had Pong. We played for hours. What'd you run?
That'll give away my age, I don't want to mention.
It was something else. So Gen Xers are willing to spend money on a small dedicated console that lets them re-enjoy games.
Very nice. Which
services?
So, yeah, this uses SQS, Simple Queue Service. We're using two services, two queues, so one to join a game and another to distribute the results.
Great.
Thank you.
Rock on.
Awesome.
Thank you. That's going to be awesome.
Rock, paper,
Pretty
scissors
addictive.
on.
I can see that.
So we've been having a lot of fun here today, hacking for about 14 hours. And yeah, so when we got here, we thought these events are really great, but you spend a lot of time kind of sitting and hunched over really bad and just kind of like pounding on the keyboard. And so wouldn't it be cool if we could create some kind of device to help us remind ourselves to take a break and walk around and stretch. So we've got our Spark Core, and it kind of sends activity data. And if you don't do anything for a certain period of time, you'll get SMS alert saying, that says no activity, Larry, start walking. So that's the idea. And kind of if you want to start stretching, jogging in place or whatever, as your activity changes, you'll get some feedback on your activity levels on the device. And you can see here some of the data we've been collecting throughout the day. And Pete's going to talk more about the services we use and the architecture.
So basically what we're doing, we've got the Spark core sending the accelerometer data to the Spark cloud, and then we've got a Java application that picks that data up and moves it into CloudWatch. That gives us very easy graphing, allows us to do some tracking, and obviously then the next thing you're going to do is set up CloudWatch alarms. That's how we kick off the SNS message to mobile device and let the user know that it's time to get back to moving around and stop sitting. We had one more mode too, where you can basically, if you hit any of the buttons on the back, it'll give you an indicator of whether you're good or not. So for those of you who want to see, I'm green right now. Where are you at?
Probably red. Oh, that's green.
You're still green. He's been still moving around
Kind
too
of
much.
shaking a little bit on
But the idea was that you'll get a gradient as to how far up the scale you are. It's a little hard to see here in the bright light, but from red to green, that gauge goes up as your activity level increases, and then as CloudWatch average would drop off as you decrease activity through your day, it would go down toward the green area to remind you it's time to get moving again, or sorry, the red area to get moving again, and that the buttons on the back would allow you to get a sort of a point in time look of am I doing well or not.
Just got another alert. So if everyone wants, they can take a stretch with me. Get moving.
No, I think it's too late. They're all sleeping out there. There's one stretch.
Any questions?
Yeah, are you connecting into a database or anything so you can track your performance over time, or against your friends, et cetera, et cetera?
Yeah, so I mean, we are storing the CloudWatch, right? So CloudWatch is a good, I think, metrics database. So we send individual points to CloudWatch, but then CloudWatch has the capability to perform aggregate operations. So you can say, what's my average for the past week or past month, and we do separate the CloudWatch data out by participant,
right.
so you can see.
Because you're
here,
seeing connected.
There's Larry and
That's
Peter.
right.
We each have our separate tracking in CloudWatch.
How are you connected to send the data anywhere?
To send this?
Yeah. So you're stretching, you're moving around. How are you sending that data to anything?
So
how are you connected?
Yeah. So the Spark core has Wi-Fi, so it's using Wi-Fi.
Got it.
Published to the Spark cloud, and then their cloud has kind of like a PubSub kind of thing. So we're subscribing to that and pushing that data into CloudWatch.
Got it.
And then we're also reading from CloudWatch because CloudWatch is kind of the engine that does aggregation. So to update the graph, it's the average of like your last, whatever.
So you have to be in Wi-Fi range.
Yes, in Wi-Fi range.
Does it measure how vigorously you stretch? Do you get more points if you
So
move faster?
The more you kind of move around, and that's something that we came up with some heuristics based on our extensive sample data. But you could refine that, I guess, as you got more data, and you got better data.
Cool.
All right.
Thank you.
Very cool.
Thank you. All right, thank you.
Thank you.
Good morning. We are the Algorithmics. You have Ryuji Takahara on Node.js, and Kinesis JavaScript SDK, Mark Chance on front-end UI and Kinesis JavaScript SDK, Eric Hammond as the cloud godfather, and I'm Will Raymond, back-end engineering and client software. We have done not just rock, paper, scissors, but rock, paper, scissors, and water tonight using the Spark device. Basically, Mark and Eric are going to demo by selecting a option, one of the 4 buttons, and make sure they can see the lights. It takes a few seconds to decide. Oh yeah, you should shake it. Always, shake those dice, man. There you go.
Oh,
Winner. So the software is basically uses a secret proprietary autonomous heuristic semi-modal algorithm to decide who wins. As you heard, it uses Kinesis to get the event stream. Python and EC2 and Cherry Pie on Python to do the web UI. Browser code that is standalone. And I think that's about it. EC2, Kinesis, and the Spark API. Just a few comments, though. We've heard tonight how difficult it might be to work with the Edison device. We found that to be true, and so we took it out of the mix. It was a pretty steep learning curve. The Spark was quite easy in comparison. And that's about it. Oh yeah, one other thing. The client software supports one other mode, which is the silent majority. In that game, it basically, a crowd of these devices could basically, people in the crowd could select one of the buttons, and whatever's the most dominant button, those people lose. And then you would continue to rinse and repeat until there's only one person.
Nice.
That's fun.
Do you use Paxos?
Sorry?
I asked if you use Paxos. Doesn't matter.
Any other questions? Okay.
No, thank you.
Thank you.
Thank you.
So, I'm Ronnie, and I'm Dave, and we are Cloud Lights. So, the idea we came up with was initially thinking about solar panels. They're becoming a lot more powerful, a lot more popular, but you don't always know where the best place to position them is. Sure, you can figure out things from your latitude and your longitude, but if you have other buildings in your area and what have you, you might not know what exactly is the best place. So we have these little sensors here that take light in multiple directions. They also take temperature readings. So you can analyze where the best place to put solar panels is. But they also work indoors. So you can place these in different places and figure out when you're getting your best light in the day, when you're getting your worst light. So this has multiple applications. It has applications in interior design. It has applications in keeping your building as efficient as possible, knowing when you want to increase the shade or decrease the shade, when to beef up AC, turn it down, stuff like that.
And you can also put multiple of these devices in many places across the house. Interior designers, they like to model how light affects a room over a period of a day. So they can just drop a bunch of these sensors inside a room, and it starts recording what the light is doing in that room throughout the day, in many different rooms at one time. So an interior designer could go in, put the devices in the house, leave them running for a day or two, and then take them out and chart how the light moves across the house. So, do you want to?
Yeah. So we used the Spark core with a couple. We just used photosensing resistors and a temperature gauge, and we posted variables. We used. We wrote a Ruby bridge that pulls the Spark core and then posts everything to DynamoDB.
Yep. And then on DynamoDB, we have an EC2 instance that reads the data back out, puts it into JavaScript files, which then get rendered on our website. And this particular website, we created it from a Bootstrap template, and then found a graphing library that worked out real nice called HighCharts. And when we combined all the pieces together, it made a nice looking site.
What services are you using? Can you say again what services are you using?
We use DynamoDB, and we used EC2.
All right.
It sounds like all of this, all the sensors are doing is in advance of what you really want to do, right? You're saying that you place these around the house from an interior design perspective, and you're tracking light. Maybe what other than light? Heat.
Temperature, yes.
Temperature, and then what decisions do you make from that?
So what we'd like to do is to be able to combine this data and coordinate it, probably using like an Elastic MapReduce, to get better information on to make better decisions on how to improve our building.
Could you put obviously, I think you could put a GPS on it and place it over the house for a week and then just give a report, right?
Yeah, absolutely. We didn't have access to GPS sensors today.
But from a practical perspective, you want to know, when do you turn the heat on and off, perhaps? When do you lower the shades and raise the shades if you're optimizing for the amount of money you're spending in the house on energy, things like that?
Yeah, those are neat ideas.
Or which plants, which plants to put where, right?
Yeah, which plants we can put in. But it also affects when buildings are nearby too, and shade and
yeah,
and
no,
other
but
plants.
I mean the practical reality is you're trying to solve, I think, for how much energy you're using to sustain that house from a period.
Whether solar is the option, more heat efficient windows.
Okay, thank you guys.
Thank you.
Thanks.
Very cool.
So our problem is your barkeeper. And barkeepers have a problem. They need to maximize profit. Beer mug should never be empty. So we over here have a business problem, have a scope statement. We also dealt with the problem, Internet of Things. We thought that if you're going to do Internet of Things, there must be a thing that you're trying to make an internet, right? So in our case, our Internet of Thing is a mug, it's a beer mug. So in a bar or casino, if any customer's beer mug goes empty, which is really sad, really, bartender only knows that if you come by and see it. So in the Internet of Things world, we should really be thinking about an internet-enabled beer mug, and that's what we're going to propose, right? So the Internet of Things solution is you can imagine a mug with that little tiny Edison at the bottom of the mug built in, and as a sensor on the side of the cup at the level where you define where below the level the beer is empty, right? It sends data to DynamoDB, to tables in there. And we actually have a website hosted on S3 to actually show the dashboard. Yes, it actually works. Yes. And when it's empty, it sends out a signal, a SNS message to the bartender that certain cup is empty. We only have 2 cups in the demo here, but you can imagine multiple cups. We actually even have a bonus at the end. It's a little bit out of scope, so I will talk about that later. But one thing to note is that we were able to put all these together using Node.js, which before today was actually pretty hard to do, right? You have to write a lot of C code and all that stuff. So this is completely JavaScript. So going forward, so in the solution, we use Intel Edison Kit, moisture sensor, Dynamo SNS, EC2, as you've seen. It is attached to the glass, but this is a prototype. In the real one, you will build a mug with the sensor thing there. And below that threshold is considered empty, right? And then we upload the whole thing to DynamoDB, and you can see that. And then we have the notification and the UI. So instead of me talking, let's talk beer. So we're going to go to a console, and that's the dashboard. So meet your bartender is starting, and let me start my backend code. It should have no problem connecting. Okay. All right, and yes. And the other thing is we have the cell phone here, so that if later on he's going to receive a notification to say the beer mug is empty. Right, so we're going to fill in cup A. The cups are mugged. This is B and that one is A. And it's going to go till the sensor level. You can see that the cup is not empty, which is a good problem. The cup is full, or is filled with beer, which is the kind of thing you want. Now, let's say we decided that to drink this up. Right, I'm trying not to spill the whole thing. Right, and then you also empty the other one. We have a lot of foam on this thing. I've got to drink it up. Drinking on the stage. So yeah, it's the foam. Sorry. We actually used a lot of beer while testing, so. So, yes, it's actually, one of them is still not empty. Hang on.
Think.
Sorry. Yeah, so I actually never reached zero. The moisture sensor never reached zero, but nonetheless, it's very low. It's at 8, it's at 10. So it actually knows that it's empty or very, very low moisture. So yeah, so the cup is now empty. If we pour it back in, or in the case, dip it in there, it knows that it's filled and it's empty.
Full.
And whenever it's actually empty, whichever cup it is, if you check the SNS message from his email, we sent it to an email because that was just a demo.
Need a hairdryer.
And
you do.
Yeah.
Like, okay, so one of them is.
All right.
Email.
Okay.
Yeah, see? Cup B is empty, cup A is empty. Don't know if you see it. It's backwards. Yeah. Okay.
All right.
So going back to the diagram, it's a little bit easier to understand if you have the diagram. Sorry, this one. That's basically what you saw. We have a sensor on the beer mug going onto the internet, and no mugs should be empty from this point on.
Awesome.
Questions? Oh yeah, the other thing is there's a big data behind the scene. So you can actually, usually the owner of the bar is really not the bartender. So you can actually see if the bartender is doing a good job keeping all the mugs filled up.
Good point.
Running reports after the fact. We actually have a bonus.
So why didn't it reflect the fact that the sensors were not in cups with beer?
It's actually supposed to be built at the side, and just now it was completely dipped in it, so it actually screwed up the top part of this sensor here.
All right.
I see. Okay.
So how would you solve that in the real product?
In the real product, you will actually have just holes directly for the sensor instead of the whole entire thing dipped in it.
Got it.
But wouldn't the foam still cover it?
Foam could cover it.
Yeah. Well, correct. Yeah. Technical issues.
Maybe it's
No
better.
foam.
Maybe it's more effective with wine.
Oh.
Maybe wine sensor.
Unless it's
Yes.
sparkling wine. Not with champagne.
Yes.
Okay.
Great.
Thank
Good
you.
stuff.
Yeah, we're good. We're good.
That was great, guys. Awesome. It's called the bottomless mug, right?
So before we show the demo, and I would like to address one of the questions as well as the motivation for this prototype. So I noticed that in the previous demo, one of the most common questions were how do you work with the other device, or how do you just make it connect to the other products. So this is what we are trying to do. So just to give a little bit of background, so none of us have a hardware background. We actually just come here for a cloud conferences, but we're just pretty interested into this hackathon. The topic. So we came up with this idea by trying to make a very simple hardware because we're not very good at that, and then we kind of like motivate us to think about a little bit wider problem, like how to make multiple devices working together. That's the whole thing. So the background of this prototype is that we are in the IoT stage, and more devices will be coming up, and including multiple categories and different types, different functionalities. So, and there will be more. And so the problem that we're thinking from user perspective is that how does user handle this many devices? And so they have to buy the device, bring them back home, learn how to use it, and just get to used to it. So, and then how to use all of them, and when there are more and more coming out. So what we're trying to do is to make all of the devices working together as a whole and automatically and gracefully. So what we're really trying to focus on this prototype is the connectivity and usability. So it's an open platform to connect different devices from different manufacturers, and also easy to use interface for user to put them together, set the rules. It's actually a rule engine under the hood, and then it's a connection to connect the potential hardware and with the software. So this is a demo. So we are going to demo. The first one is to connect the button and push the button on one of the device, and then show the yo. It will yo one of a user. So then whenever it's the other way, yeah. So this is one of the scenarios. So just imagine like a user with a smart wearable device, and he wants to tell his friend by not using his smartphone. So then the other scenario that we are simulating is in the home environment, is that connecting the sound with the light. So when there's a sound happening, the other device LED will blink. Sorry, we're still calibrating the threshold of the sound sensor. Right. Okay. So we basically the key point of this prototype is just the openness and and also the usability. So what we're trying to do here is this is the this is interface that we are trying to provide to the user. So when they get multiple devices, we'll provide them like a very easy to set rules engine for them to set up, and so you can actually trigger button with different services that you're using, beep, and everything will happen on the cloud. So when they're even away from the device, they're still able to make the configurations. Yeah, so we just made the button with the beep. So can you push the button? Yeah. So now it should do the beeping. Let me try that again. Can you push the button again? Yeah, here we go. So that's the whole idea. Any questions?
Yeah, what
services sorry.
Same thing. What services?
So far, we're using Elastic Beanstalk for the backend services, and also Kinesis for the message distribution. And we plan to use DynamoDB to store multiple data we run out of time. So.
Thank you.
Good. Thank you.
Thank you.
Okay, so we start from number 3. So number 3 is team number 30, SmartHouse. Yeah! So come up, please. You can actually I would like you guys to just say your name and where you're from, where you came from.
Okay. My name is Antonio. I'm from São Paulo, Brazil.
Pedro, Brazil as well. I'm Gui, also from Brazil.
All right. And so, all of them, or just one? Oh, really? Oh, that's cool. So each of you get a $250 gift certificate from AWS that you can spend in very cool cloud services. So, thank you. Thank you. Here we go. We have 4 here. What do I do? Just give it to them. All right. Thank you. $1,000 of AWS credit. It's team number 19th, Sensei Grow. Yeah. Very good. All right. Again, say your name and where you're coming from.
Cameron Pope, Denver, Colorado.
Hey, my name is Ankit. I'm from India.
Very good. And so, congratulations. We all thought that was actually quite good, right? Very impressive. And actually, Mike thought that might actually save the world eventually. Yeah, exactly.
At least get some better wine.
Yeah, that's good. So you have, each of you, a gift certificate for $375 of credit and times 2. So each of you get 375 times 2 that I cannot really calculate in this moment. Of credit from AWS. Thank you so much. And our gratitude, of course. Yeah. Okay, so the winner tonight, and this is like, ooh, that's a lot of money, is team number 12. Don't panic. Hey, you guys are the winners. It's amazing. It's amazing. Wow, this is a lot of money. Are we sure? I don't know. All right. Names and...
I'm Paul, I'm from London.
Lloyd from London.
Hi, I'm Ricardo from Hong Kong.
Hi, I'm John from Hong Kong.
Your prize tonight is a number of gift certificates of $500 each. So you can use Go Crazy and Don't Panic using all this money. And thank you so much. And congratulations for being the winner of the first IoT Hackathon. You're going to be remembered. Thank you. Yeah, big picture, big picture. Okay, so again, thanks everybody. Thanks every single one that participated today. I can't believe we got developers waking up at 7 a.m. and leaving at midnight. I wish I could pull that off in AWS. So thanks for that. And we're going to see you next year for more IoT excitement. And again, thanks to all the staff. And congratulations to the winner. Thank you very much.